Hey everyone, let's take a look at section 5.3 now. Um, we're going to look at the trig functions in a slightly different way as far as the ratios of sides go. So this is the definition of all of them in a right triangle specifically. You can always think of it in these terms. So for example, the sine of an angle A is going to equal the side opposite A divided by the hypotenuse. So when you're looking at these definitions, here's a pretty good reference triangle to use. So if A is here, then the side opposite of A would be the one side that just doesn't touch that angle. That would be opposite. Okay, and then the hypotenuse is always that longest side, which is always opposite the right angle. Right? So hypotenuse does not touch the right angle over here. Okay, so I labeled this opposite, meaning opposite of angle A, opposite A. Okay, and so the sine is always going to be that ratio, opposite divided by hypotenuse. Right, just definition of it. And then there's one for all of them, right? Cosine, tangent. The ones I focus on are the main three, sine, cosine, tangent, because I know the other three are just going to be the reciprocals. So the ones I always remember are just the sine, cosine, tangent. Okay, so one memory aid you can use for this, which maybe you've heard before if you've had some exposure to trig, is SOHCAHTOA. SOHCAHTOA. Right. So this is a memory aid for these definitions. So the sine is equal to the opposite divided by the hypotenuse. So SOH. Cosine is the C, is adjacent divided by hypotenuse. When we use that word adjacent, that's the angle. That's the side that's right next to the angle, right? So in this case, this is adjacent to angle A. And then finally, tangent is the opposite divided by the adjacent to angle A. Okay, now if you changed all of these to angle B, right, then the opposites and adjacents are going to change, right? So like if, for example, if we had the sine of B, right, now we're talking about this angle, the side that's opposite B would be over here, right? And then the hypotenuse would be here, okay? So if I use the letters in this triangle, that would be the B divided by the H. Still opposite of B divided by that hypotenuse. I'm really messing up that triangle with all my lines there. Okay, so we're going to use these. We'll keep referring to them, but the important thing is to stick to the definitions and always pay attention to what your angle is. Where is it in the triangle? Because that's going to define what the side opposite is and the hypotenuse, etc. Okay, so let's do an example. Here's a right triangle, and it says find the sine, cosine, and tangent values for angles both A and B in this triangle. Okay, so let's start with the sine of A. So there's A. Right? Sine of angle A. What would that equal? Okay, so remember, it's always the opposite divided by the hypotenuse. So I'm looking at my triangle and looking at what side is opposite, which would be over here, right? Away from the angle is opposite. That's a value of 7. And the hypotenuse is the longest side, 25, opposite the right angle here, right? And so there would be the answer, okay? So as long as you know the values of all the sides of the triangle, you're good to go, okay? How about the sine of B? Okay, so the sine of B, it's still opposite over hypotenuse, right? That's the ratio of the sine, but now the angle is here. So if we're talking about this angle, then opposite is the 24, right? Hypotenuse still 25. Okay. How about cosine of A? Cosine is adjacent over hypotenuse. Okay, so adjacent here, the A is adjacent of angle A. I know a lot of A's here, but we have angle A, and then I'm using A for adjacent. Hope that's not too confusing. So if I'm talking about back to this angle, what side is adjacent to that? It's this side, is the 24, right? And then the hypotenuse we already know is 25. That hasn't changed. Okay. The cosine of B, we're still talking adjacent over hypotenuse. So if I'm talking about this angle up here, what's adjacent to it is the 7, right next to. Adjacent is next to. Hypotenuse is 25. All right. Finally, we have tangent. Tangent of A. So we're back to my angle A over here. Tangent is opposite over adjacent. So you don't use the hypotenuse at all for tangent. So opposite is 7. Adjacent is 24, right? So that's 7 over 24. So really it's just about identifying the correct sides to get these answers, right? And then tangent of B. So now we're up here, the angle B, it's still opposite divided by adjacent. So if we're talking about the angle B, opposite B is the side 24, right? And adjacent to B is the 7, okay? All right. And, we could have used these definitions in the previous sections, right? When we're looking at angles and standard position and all of that, it still works. Okay. So if you like this better, you can use it a lot. We'll be using it a lot this semester. So think about that SOHCAHTOA and make sure you first identify where your angle is, which then defines what's opposite, what's adjacent, blah, blah, blah. Okay. Something a little new here. We have some more identities. Keep your list going, cofunction identities. Now we are going to kind of, well, if we look back here, check this out. There are some repeated answers, right? Notice that the sine of A and the cosine of B are equal, right? So if I look at sine A and cosine B, those are the same, right? So are sine B, cosine A, right? So those are called cofunctions. They're equal. One thing you know about the angles A and B, because the angles in a triangle add up to 180, and if it's a right triangle, you have one of them being 90, right? So A and B, angle A plus angle B is also 90. Right? Those two always add up to 90 in a right triangle. Okay, so those are the cofunctions. That's where it's coming from. And that's what this is meaning right there, right? The sine of A is equal to the cosine of B, or in this case, we're just writing it as 90 minus A, right? And there's cofunctions for all of them, right? So you can refer to this, but all of them are in that similar fashion. Okay, so if you have a problem like this where you have number 2, the sine of 52 degrees, write it in terms of its cofunction. The cofunction for sine is cosine. Whoops. Don't want to do that in highlighter mode. Cosine. And then what you're really finding here is the complement, right? Cosine of 90 minus 52, right? Which equals the cosine of 38. That would be how I would write the function in terms of its cofunction. For tangent, I would use that one, right? And it's the same formula. The cofunction for tangent is cotangent. The cool thing about the wording is that they're all in that same fashion, right? Sine, cosine, tangent, cotangent, secant, cosecant. It has the co in it. So tangent, I would do cotangent, and I just got to find the complement of 35, which I could just do on my calculator on my head real quick. 55, cotangent 55, right? the last one, the secant, the cofunction for secant is cosecant. Okay, so secant, I would write cosecant and then find the complement of 74, which is 16. And there we have it. Cool. Okay. The next thing, which is super cool, and we'll be using these a lot this semester, are 30, 60, 90 triangles. Yes. Okay. So where do 30, 60, 90 triangles come from, and what are some properties of them? So what we're going to do is start with an equilateral triangle here. Equilateral just means all of the angles are the same. So we've got 60 degrees in all of the angles there, and we're going to bisect it, cut it in half, right? Also, just to have some numerical values, we're going to assume that all the sides are unit 2, right? So notice all of them have 2 there, okay? And we're going to bisect that, which is over here, right? Notice what happens. If you bisect it, that 60 degrees that was up top here now becomes 230s, okay? And then we have 90 degrees down here, right? So those are specified as 90 right there. We cut that bottom side in half, so that 2 becomes 1 and 1. All right. And what we've created are two 30, 60, 90 triangles. That's what a 30, 60, 90 triangle looks like. All right. It just has angles of 30, 60, and 90. Now, it turns out there's some properties, special properties of those. Okay. Also note that the side opposite the 30 is 1, and the hypotenuse is 2. All right. And we just randomly selected 2 to begin with. I mean, had we selected 4, then we would have 2 here, half of 4, and then 4 there, right? The property is that the side opposite the 30 is always half of the hypotenuse, right? Or another way to say that, the hypotenuse is always double the side that's opposite 30 degrees. Now, how about the side that's opposite the 60 degrees? This one that we have labeled X right now. We could use Pythagorean theorem to solve for X and figure out what that value would be. Okay, so let's do it. So Pythagorean theorem, let's do 1 squared plus x squared equals 2 squared, right? A squared plus b squared equals c squared. All right, so 1 squared is 1 and 2 squared is 4. So I can just subtract that over. That would be x squared equals 4 minus 1, 3. And then square root both sides, and we get x equals the square root of 3. Okay. And so I put that down here, right? So this, when I complete it, is very useful and it's worth memorizing. So in the 30, 60, 90, the sides will be in that ratio, 1, 2, and 1 root 3 and 2, okay? And it's always going to be in proportion, right? So if you doubled the 1, so if I look at another 30, 60, 90, 30, this one's not as pretty. But if I put, well, just whatever I put here, right, let's times that by 3. And then I'm going to times the hypotenuse by 3, and I'm going to times the root 3 by 3, right? This would just be a larger 30, 60, 90 triangle. But the sides are always going to be in that ratio of 1, root 3, and 2, regardless of the factor. Okay. So using that, we can find the 6 trigonometric functions for a 30-degree angle, right? I mean, we could just use this triangle right here, right? Because we got that nice 30, 60, 90 already generated, right? So what would the sine of 30 degrees equal, right? Remember, it's opposite over hypotenuse. And in this case, opposite is 1, hypotenuse is 2. Sine of 30 degrees is 1/2. That's just a fact. It's true, even though we use this triangle, which it seems like, oh, we just use special numbers, but it doesn't matter. Even if you use this one, it would still work out to be 1/2, right? It would be 3 divided by 6, which reduces to 1/2. So the sine of 30 is always 1/2, okay? And that's going to be true for all of these when we generate all 6 of them, right? How about cosine 30? Adjacent over hypotenuse. Adjacent is root 3. And hypotenuse is 2, right? Root 3 is right next to that 30-degree angle. Okay. Cosine of 30 is always root 3 over 2. Tangent 30. Tangent 30 is opposite over adjacent. Opposite is 1. Adjacent is root 3. So 1 over root 3. Rationalize that. You're probably getting pretty good. Getting pretty good at rationalizing. Multiply by root 3 over root 3. There you go. Root 3 over 3. Okay. That's the tangent of 30 degrees. Now the other 3, because we said it said 6, are just the reciprocals, right? So let's do cosecant 30. Just flip over the sign. So 1 over 2 becomes 2 over 1 or 2. Secant 30. Flip over the cosine of 30. Just 2 over root 3. And just multiply top and bottom by root 3. You get 2 root 3 over 3. And then finally, we can squeeze in a cotangent 30. I would flip over this one, right? The one that's not rationalized, because when you flip it over, it will be rationalized. So I flip that over, it's just root 3 over 1 or root 3. And there's your 6 trigonometric functions of the value of 30 degrees, okay? The next thing we'll do is look at some more special triangles, but I'll do that in the next video. So that's a good stopping point for now. Hope it's making sense. If it's not, let me know. We'll pause and restart in the next video. Okay, talk to you later.